Existence resembles a texture, elastic like a trampoline net. Turn this trampoline net into a pretzel and permit yourself to go in reverse in time. Have you ever questioned what's genuinely out there in the universe? What amazing secrets the universe may be hiding from us? Well, you're in for a ride. We have a discovery so giant, changing everything we thought we knew about the universe. Brace yourself as the eminent American physicist Michio Kaku reveals a discovery that is nothing short of revolutionary. Exposed by none other than the incredible James Webb Space Telescope, it may have proven that time doesn't exist. Ready to plunge into a space-time enigma that will turn your reality upside down? The James Webb Space Telescope is basically the Hubble Space Telescope's bigger, cooler sibling. Launched on Christmas Day 2021, this telescope has taken up residence in space, illuminating mysteries from the universe's darkest and most distant corners. It resembles the ultimate time machine, equipped with powerful infrared instruments that make it ideal for peering into the past. How, you ask? Well, its extraordinary resolution and sensitivity allow it to detect incredibly old and faint objects that even Hubble couldn't capture. We're talking about distant galaxies and celestial bodies from the early universe, those elusive entities that have been playing an incredible cosmic hide-and-seek with us. James Webb is helping us piece together the universe's grand jigsaw puzzle, one infrared image at a time. Now, imagine you're at an art gallery, strolling around great pictures captured by the James Webb Space Telescope, also known as JWST. The imagery is stunning, with distant galaxies glowing across the vast canvas. Yet, among the astronomers and cosmologists, you see shock and disbelief. There's a sense of disturbance, as if they're staring at a Picasso in a room full of realists. A common phrase you hear is, "This is surprising, so what's the fuss about?" What's shaken the very foundation of their understanding of the universe. Although the official papers are silent about it, the main issue lies with a theory they hold dear, the Big Bang Theory. The theory posits that our universe began in a huge explosion around 14 billion years ago and has been expanding like a giant balloon since. This theory has been the foundation of cosmological understanding for decades. Now, the new images from the JWST seem to question its validity, sending shockwaves through the community. Why is everyone so surprised? Well, the galaxies captured by the JWST aren't behaving as they should according to the Big Bang Theory. They're too small, too smooth, too old, and there are too many of them. Let's try to simplify it. If you imagine the universe as an expanding balloon, galaxies shouldn't look smaller as they move away from us. After a certain point, they should start looking bigger because their light probably left them when they were closer. It's a strange yet fundamental twist in the expanding universe concept. But the images from the JWST show galaxies that are about the same size as the ones close to us. It's like you're expecting your distant friends to appear as tiny dots in the distance, yet they are right next to you, just as clear as day. Strangely, they show galaxies appearing smaller than we'd expect, even those that shine brighter and pack more mass than our own Milky Way. These photos show galaxies that seem several times smaller than the ones seen through the Hubble Space Telescope, HST, despite their greater luminosity and mass. Furthermore, these galaxies also have significantly higher redshifts, which, in layman's terms, means they're supposedly moving away from us at faster speeds. You might think, well, that's odd. And you'd be correct, especially if you're working under the assumption that we live in an ever-expanding universe. Some time back, in 2014, a few scientists had already pointed out this anomaly. They examined HST images and found that galaxies with redshifts up to 5 seemed to match what you'd expect in a non-expanding, regular space. It was speculated that the JWST would continue this trend, and it has, even for galaxies with redshifts as high as 12. In simpler words, the JWST images show galaxies that appear the same size as those near us, as if the universe isn't expanding and redshift is just a factor of distance. But if we still cling to the Big Bang Theory and its expanding universe concept, we're left with a rather baffling conclusion. These distant galaxies must be tiny to offset the supposed optical illusion created by an expanding universe. It's a bit like imagining a grain of sand with the brightness of a spotlight. Take, for example, a galaxy named GHC2 that the JWST detected. It's far brighter than the Milky Way, but is estimated to be only 300 light-years in radius compared to the Milky Way's 50,000 light-year radius. Its brightness per unit area would be 600 times that of the brightest galaxy in our local universe. Not just that, its density and that of several other new galaxies would be thousands of times higher than the galaxies we see around us today. Now, when you consider these tiny and smooth galaxies, the idea of an expanding universe and, by extension, the Big Bang Theory starts to crumble. And that's why these findings are causing quite a stir among astronomers and cosmologists. Over the years, the Hubble Space Telescope's pictures posed a challenge. The photos suggest the existence of numerous galaxies, dense and strong, much like Mighty Mouse from old cartoons. These galaxies are a tough puzzle for themselves, and with the new James Webb Space Telescope, things have only gotten trickier. To make sense of these unusually small galaxies, theorists have advanced an idea. It's as if you're playing with a tiny toy car, a magical one which, despite being only a centimeter long, weighs as much as a real SUV. They suggest that these mini-galaxies smash into each other over billions of years, merging to form the standard galaxies we see today. It's like the toy cars colliding and growing to appear as real SUVs. But here's the twist. The JWST has taken a close look at these galaxies and found no signs of such cosmic car crashes. You'd expect these colliding galaxies to show some signs of damage, right? Maybe look a bit jumbled or battered like a car after a minor collision. But that's not what we see. Instead, the JWST reveals galaxies that are smooth, sleek spirals, just like the ones we see nearby. There's a stunning lack of cosmic bumper marks. In fact, one study, aptly named Panic, highlights that there are 10 times more of these spiral galaxies than the theorists had anticipated. This is akin to finding a busy highway with speeding cars but no accidents. This is a pretty significant blow to the collision theory. Without any signs of cosmic mergers, the idea that these tiny galaxies somehow grew into their grander counterparts falls apart. If they didn't grow in size, it means they weren't small to begin with. Thus, the optical illusion we'd expect from an expanding universe doesn't seem to be there. Without this illusion, the concept of expansion loses ground. Consequently, the growing unease among Big Bang enthusiasts is understandable. The existence of these small and smooth galaxies suggests that the universe may not be expanding. And if it isn't, the Big Bang Theory suffers a major blow. And there's another aspect to consider: the age of stars. The Big Bang Theory suggests that everything came into existence following the enormous explosion. However, if these galaxies existed before that, then it would mean the Big Bang didn't happen. This could be a game-changer for our understanding of the universe's origins. Consider the James Webb Space Telescope as a time machine. In the words of Kaku, it's able to peer billions of years back into the universe, capturing images that shed light on the universe's beginnings. This extraordinary device isn't just snapping photos in our familiar visual range. Rather, it's focused on the infrared, revealing hues of galaxies so distant we could never observe them with our unaided eye. Now here's the fascinating part. These colors aren't just beautiful. They're telling us about the age of the stars in these galaxies. Young, fiery stars burst in vivid blue while their older, cooler counterparts, like our sun, glow in shades of yellow and red. By analyzing these colors, cosmologists can estimate the age of the star populations in these distant galaxies. According to the Big Bang Theory, the farthest galaxies in the JWST images represent a cosmic snapshot from around 400 to 500 million years after the universe's birth. However, some of these galaxies seem to house stars that are over 1 billion years old. Now, if you've been following the Big Bang Theory, you know that's a big problem since nothing should be older than the Big Bang itself. Another assumption, if the Big Bang Theory is correct, is that as we look farther into space, meaning looking further back in time, we should see fewer and fewer galaxies until we reach a point where there are none, a cosmic dark age, if you will. However, it seems to be a different story. Galaxies as massive as the Milky Way were already quite common even a few 100 million years after the supposed Big Bang. The new images show that there are at least 100,000 times more galaxies than expected at high redshifts, over 10. So, the question is, how could so many large galaxies form in such a short time? The answer is they probably couldn't, at least not under the constraints of the Big Bang Theory. And that's why these discoveries are challenging the foundation of our understanding of the universe. On top of that, there's a deeper philosophical quandary: the nature of time itself. Modern physics operates on the assumption that time exists, a fundamental concept deeply embedded in our understanding of the universe, intertwined with Einstein's theories of relativity and countless scientific principles. But what if time, as we understand it, doesn't actually exist? This hypothesis, though radical, isn't entirely new. Renowned physicists like Julian Barber and Carlo Rovelli have long argued that time might not be a fundamental property of the universe. Instead, they propose that what we perceive as time is merely an emergent phenomenon, a byproduct of more fundamental aspects of reality. Now, while these ideas may seem esoteric, they could potentially explain the enigmatic findings of the JWST. If time doesn't exist in the way we traditionally understand it, the discrepancies in the ages and sizes of distant galaxies become less problematic. Our understanding of cosmic history would undergo a dramatic transformation, requiring us to rethink not just the Big Bang Theory but the entire framework of modern physics. This hypothesis, while fascinating, remains highly speculative. The scientific community will require substantial evidence to support such a paradigm shift. At the heart of this cosmic conundrum lies the very nature of time and the universe's origins. As we continue to explore the cosmos with increasingly sophisticated tools like the JWST, we may uncover more clues that challenge our understanding and push the boundaries of human knowledge. The journey toward unraveling these mysteries promises to be an exciting and transformative adventure.